The network is not so good. What's wrong with this network? Thank you for coming back to our second class. So we're going to begin this lesson with C++ variables. Okay. So what are variables in programming or containers for storing data? Any data that you want to keep, whether you want to type a text message on WhatsApp, there's a variable that keeps all those characters that you type. Okay. So in programming, the containers that keep the numbers, the text, the strings that you write are called variables. Okay. So we have got different types of variables. Okay. And the types of variables are also called what's this? Keywords. Okay. Or maybe let me say keywords. Let me say keywords are like uh, words that are preserved in programming languages. Okay, you can't use them for anything else. You can't write them and use them for something else. Those words are called keywords. So the types of variables are keywords. You cannot use them for anything else other than that particular purpose that were put into the program. Okay, so the most common variable that you're going to encounter almost in every program that you're going to write is what? The int. Okay, this type stores integers, or rather whole numbers without decimals. Okay, numbers that you find on the number line. All right, these are the integers. Then the other type that we're going to discuss here are double. Okay, double with a small d like that. Okay, this variable stores floating point numbers or numbers with decimal points. Okay, numbers with decimal points, they are called double. For example, 19.99 or negative 19.99 or 0.1 or 1.2. All numbers with decimal points are double. Okay, then the other type that we have is a character. We, in short, we just write ka or cha. I don't know how you can pronounce this, but that's how it is written in programming language C++. Okay, this one stores a single character, okay, such as A, B, these are supposed to be surrounded by a single quote, okay, like these two apostrophes here, single quotation marks, okay. Then you are defining a character. A string is also another type, okay. So when typing your type or when writing your type, make sure that the type has got a small letter, starts with a small letter. Don't capitalize your types, otherwise you are moving away from a type, you are going to objects, which we are going to talk about later on. Okay, strings can store text. For instance, you want to write um, a message to your partner, you want to write um, anything, you want to write notes, you are keeping the text in a variable of type what? String. Okay. Yeah. So you are in short, variables are like memory spaces where you put your data, anything that you want to manipulate, anything that you want to store. So since we've got different types of data, you are going to use different types depending on what you want to keep. And like I said earlier, you need to be sure about the type of data that you are going to keep so that you can preserve memory. You can't assign say maybe a double to numbers where you want to use integer, because doubles are going to use more space than integer. Okay, so you need to understand how memory is allocated so that you can know when to use which type of variable. Okay, then we're also going to talk about uh, the boolean. Okay, so you just write bool like this. This one stores two types of values, true or false. Okay, one or zero. That's the boolean type. So moving ahead, we're going to discuss how to declare or create variables. Okay, to create a variable, firstly you specify the type, okay, the type that the variable is going to have, and then you assign it a value. Okay, so the syntax is type, then the variable name and the value. When you do this, when you write the type, the variable name, and you give it a value, then this is initializing your variable. Okay, you have created the variable, you have declared it, and given it a value. You are initializing your variable. But you can just declare a variable, you say type and the variable name, then you're just declaring it. But when you do this syntax that is written, which is written here, is initializing. Okay, so the type is one of the C++ types that we discussed earlier: integer, strings, boolean, double, okay, character, all those. And the variable name is the name of the variable. Okay, later on this variable name is going to be described as an identifier. Okay, so variable names have names like x or my name, depending on what you want to keep. Okay, then the equal sign is used to assign values to the variable. So in programming, this one ceases to be equal to. Okay, but you're going to call this one as an assignment character or operator. Okay, assignment operator. To create a variable that should store a number, look at the following example. Okay. For instance, you want to store a number, your age. Say you are 5 years old. You're going to say five, five. Okay, five. What type can I use? Can I use string? Yes, string is going. It can work because any character that is on the keyboard, any number, any character can be converted to a string. But we want something that we can add, subtract, a number. We're going to use int. Numbers don't come in decimals that no, I'm 15.5 years. No, don't do that. And then if you want to print out this number to the console, you can write cout insertion operators, then you call the variable like this. Okay, I hope you can see this. Okay, moving forward, you can also declare a variable without assigning the value and assign the value later. So this is what I was talking about earlier on. Say when you just write your variable and its type, you have declared it. Okay, but when you give it a value like this, then you have assigned a character. When you write everything clear, you write int my number and you give it a value, then you have initialized it. Okay, then note that if you assign a new value to an existing variable, it will overwrite the previous value. So in your program, when you write, you declare a variable and give it a number or a value, you initialize your variable. Later on, if you don't use that number or that variable and just write the variable the same way you wrote it in the first place and assign it another value, the first value is going to be overwritten and the new value is what's going to be the current value of that variable. Okay. So for instance, we said our number is what? My num is equal to 15. Okay. So my num is equal to 15. And then later on in the program, I say my num is equal to 10. Then when I say see out my num, I'm not going to get 15, but rather I'll get 10 because 15 will be overwritten. Okay. So when you declare a variable the first time, you need to specify the type. But later on in the program, you can just call the variable without the type, like we have done here when assigning my num to what? To 10. So there are other data types that yeah, there are other data types that we can talk about. For example, the integer, double, floats, chart, or sorry, character, string, and boolean. Moreover, we already talked about these anyhow. So displaying variables. When you want to display a variable to the screen, the previous class we had, in the previous class we're told to say when we want to print out something to the screen, we want to show something to the screen, what we use is the cout object. Okay, we use the cout object together with the what? The insertion operator to so to display, if you want to display a variable, you're going to uh, initialize your variable. Say my age is 35. So this is the syntax that you use when displaying your variable. Okay, you don't put the quotation marks to a variable if you want to get the value inside the variable. When you put quotation marks to the variable, it's going to be like a string. Okay, it's going to be like a string and it will be printed out as my age but not 35. But if you want to get the value inside this variable, you just call it like this. Okay. And every statement in C++ ends with what? A semicolon. When you forget putting a semicolon, this line is going to be considered to be part of the second line that you're going to write down. So to tell the compiler, say this statement ends here, you need to specify, you need to write this semicolon, okay? So variables, since we said variables are containers of data. Now, for instance, you want to add the data inside your containers, okay? You want to add your data inside the containers. To add a variable to another variable, we use the plus operator, okay? Addition operator. For instance, you say int x is equal to 5, int y is equal to 9. Then we declare another sum that's going to hold the addition of 5 plus 9. So we can use variables to add 5 plus 9 by just calling the variables, say x plus 5. These are more like references to these values. And when we decide to print out sum, it's going to give us the the number that you're going to get, the sum of 9 and 5. So you say cout sum. When you put uh, quotation marks to this sum, what you get is sum. Okay, let me go to VS Code so that I can explain this. I'm just going to erase this. Okay, I'm just going to erase this and clear. Okay, so for instance, we say int x is equal to 6. Okay, you close it. That statement ends there. Then you say int y is equal to 3. Okay, then we declare another variable. We call it sum. Okay, int sum. Sum is equal to x plus y, and we close, the statement ends there. Okay, then when we say cout insertion, when I put quotation marks and say sum, let me show you the output of this when we compile our code. Okay, when we compile our code, we are going to get a statement saying sum, but not the value, because we know the value. Say the value of adding 6 and 3 is what? Is 9. Is it still running? Okay, it's taking time because sometimes the computer misbehaves, but let's just be patient. Okay, we go back to our slides, we'll go back to the code, but we can be moving forward while we wait for that one. I'll explain a bit later. Okay, so if you have noticed in the previous code that I'm from writing, you find that you are repeating. Okay, you are repeating int x is equal to 5, int x is equal to, or int y is equal to 3, int z is equal to shan. That's going to be like a repetition of the same type. So if you are declaring multiple variables of the same type, you can actually put them in one line, but you need to separate them with commas. When you when you declare a variable, you assign it a value, you separate it with a comma. But also you can declare a variable, multiple variables using one type without giving those variables values, and initialize them later on when you want to use them. Okay, so let's go back to VS Code. We see if something has happened. Okay, so it actually ran, but it was just stripping. So if you have noticed here, if you have noticed here, it's giving it's giving us some, but not the value that we're expecting. Okay, when I change here and remove the quotation marks, okay, I remove the quotation marks, what I will get will be different. I'll get a different result. Okay, so let's see what it has in stock for us now. It's really taking long. Okay, I don't know what the matter is with this computer today. But anyway, like I was explaining, you can declare multiple variables of the same type in one line using one type, like the way we did it here. Okay, so when we say int x is equal to 5, y is equal to 6, and z is equal to 50, and when we say c out x plus y plus z, this is going to add these, okay, 50, 56, and 61. That's what we're going to get here. Okay, so you can also assign the same value to multiple variables in one line. Okay, you want to give different variables the same value, you can also use this syntax. You say x is equal to y is equal to z, and z is equal to 50, meaning that the 50 is equal to all of these. Okay, each of these has got 50 in them. So when we add, our expected output here is 150. Okay, so moving forward, identifiers. Okay, the C++ variables, they're also called what? Identifiers. Okay, these identifiers, they they describe a something unique in the program. Okay, something unique in the program. Each identifier is going to identify something which is unique in the program, and each identifier should be unique, because if you use the same names to give a variable, or you use, they are going to be contradicting. Okay, but the last one, like we said earlier on, we said if we use the same values or the same name to assign different values, the last core of that variable is what's going to be the final value of that variable. So if you write my name the same way, you say my name is equal to Banda, and then later on you say my name is equal to Piri. It's the Piri is what's going to be the final value of that variable. Okay, is what's going to be stored in the variable. So identifiers need to be unique. Okay, identifiers can be short names like x and y, or more descriptive names. Okay, age, sum, total volume. You know, when you are writing a program can have thousands of lines, and then later on you want to edit your program, then you come back and then find that you are writing X and Y. How are you going to know that this variable is the one which keeps say maybe it's an account number? How are you going to know that? So it is better when you are writing code, because you're going to a program, you're going to understand the program to its depth. So you need to write descriptive names. If a variable is going to be storing say account numbers, you need to write that to give that variable a name that's going to describe an account number, so that next time you come back, you're going to know, say, oh, this variable, even without reading comments, you're going to know this variable, my account number is talking about account number. So maybe if I change this code, this variable here, modify it this way, I'll be able to solve the problem that we want to solve. So it is better use descriptive names if it's age. Okay, so the recommended way of writing identifiers is using descriptive names. X and Y can be used when you're practicing small code, but if you're writing something which is serious and complex, use descriptive names, because this might come back to you and attack you and give you headaches. Okay, so for example, if I say int m is equal to 60, okay, it's okay. We understand this one. We're assigning 60 to m. Okay, we're storing 60 in this container m. But what is m? We don't know what m is. It's just a variable. But when I say int minutes per hour, okay, we know, even if I didn't put the value this side, we know that there are 60 minutes per hour. So if I say 60, you know that, okay, 60 here, or this variable here, stands for 60 minutes per hour. You might want to use this variable somewhere else in your code. Okay, let's check on our VS Code if it's run. It's funny today. Yeah, so our VS Code ran successfully. As you can see, 6 plus 3 is 9. So we got a 9 here. Like I was explaining, if you put uh, quotation marks, okay, if you put quotation marks, this is going to be considered as a string, and the string is going to be output as sum. But if you write it like that, it's more like a reference to this sum. Okay, and this sum is storing the sum of x and y, which is 9, and that is why we're getting what is stored inside, not the string sum. I hope you're clear here. Okay, so let's move forward, guys. We're almost done. Classes are going to be short. So we have general rules for assigning or for naming variables. Okay, the general rules for naming variables are: number one, names can contain letters, digits, and underscores. Okay, only these letters, digits, and underscores. You cannot put a space in a variable. Once you write a space, then you have ruined everything. The word that follows the space is going to be considered as an error or something else. Okay, you cannot put special characters, percentage, hash, exclamation marks, a bracket. You can't do all those things. Okay, then names must begin with a letter or an underscore. Okay, so this simply means that even though we accept digits in a name, you can't say to banda. You can't say that. But you can say banda 2 or underscore banda. Okay. Then, like I was explaining earlier, names are case sensitive. Okay. For instance, when you say my age, notice that my age here, M is not is a small letter. Okay. M is a small letter here. Okay. It's not capitalized. So my age is not the same as when we capitalize M, say my age. These two are different. You can assign this one 35, you can assign this one 30. They are going to store those values. But the very moment you change this M or this one, you capitalize this one or you make this one as a small letter, then you'll be declaring the same variables. And the last one is what's going to be the assigned value for that variable. Okay. Also, when giving variable names, you can't use what? Reserved words. Okay. Reserved words, for example, keywords. Okay. Those keywords that we talked about earlier, to say int is a keyword. Those words are reserved. You can't use them. Static is a reserved word because they have a specific purpose in the program. Okay. They have a specific purpose in our programming language. So we can't use it as a variable. We need to avoid it at all costs. Then we can also talk about a constant or constants. Okay. They are variables that you don't want to change the entire lifetime of your program. Okay. For example, when you get a calculator and then you write pi, we all know that pi is equal to 3.142. Okay. So this number, until your calculator dies, this number is going to remain constant. We don't want to change it. Okay. So what we do is we give this reserved word const as our first statement or our first word, and then the type, and then the variable name. So pi in this case. Okay. Const int pi. We're using int here because we're using, sorry, this is actually, this shouldn't be int because it's a double. There's a point there, so it's supposed to be double. Okay. Supposed to be double. Const double pi. Okay. The pi 3.142. This is constant. It will never change. Come rain, come sunshine, it will never change. So variables that don't change, you give them the keyword const. And if you try to change it later, the program will crash when you run it. It will cause an error. Okay. That's what's going to happen. And you're just going to have bugs all everywhere. So we've talked much about outputting data to the screen, variables, and whatnot. So we can also talk about user input. Okay? User input. You have already learned that cout is used to output or print values to the screen. Now, sometimes users want to interact with the program. For example, the calculator is the closest example that we have. Okay. You want to punch, you want to add 1 plus 1 in your calculator. The other day you want to punch 2 plus 3. That is user input. You're interacting with the program which is inside your calculator. Okay. So in C++, for us to be able to type when we press a button and it appears on the screen, we use the object cin from the standard library. Okay, cin. Okay, which is used to get user input. Cin is a predefined variable that reads data from the keyboard with extraction operator. Okay, this is the extraction operator. Earlier on, we talked about the insertion operator, and the other one is the extraction operator. Pay attention that these are facing in different directions. Okay, the very moment you don't understand this, you're going to be getting errors. Okay, for example, like I said, there are times where you want to initialize your variable later on. This means that you can declare a variable, say int x. You declare a variable int x, and later on, you want to assign this variable a value. You can write a simple code to say cout, type a number, and then in your program, you call cinx. This is not going to appear on the screen, but this is what's going to appear, and your program will block until you enter that number and press enter. Then this line is going to be executed. So your number is x. The value that you pressed is what's going to be displayed on the screen. So guys, I think our classes are just going to be 30 minutes long, but let's leave it to 19 hours so that we can ask questions where we're not clear and whatnot. Otherwise, this marks the end of our session. Are there any questions? Please use the chat section if you are with me, or just leave a comment if you are late for class. And when I find time, uh, I'm going to be responding to all your questions. Okay, I'm going to be responding to all your questions.